everyone. Happy Wednesday, and welcome to a brand new video and a brand new unit. So we are done with polynomials in the sense that we're moving on from the unit, but they'll still pop up from time to time, and you'll definitely see them in the future. And we are into the next one, which is relations and functions, and we're going to launch into this unit. So this will take us probably about 2 to 3 weeks to finish up this unit. And it's all about graphs, essentially. How can I represent the relation between two things? So that's what we're going to dive into today. And we really deal with graphing a lot. You deal with equations a lot. And it's that relationship between two variables. So with that said, let's jump right in and start our next unit. Okay, and here we are, workbook page 389, start of the next unit, which is relations and functions. And this first lesson is kind of a review of things we should know and looking at what's going to be important in this unit. So to start, it reviews the Cartesian coordinate system, or normally we call that the Cartesian plane. And it's got this whole, write-up about René Descartes, or however you would say that name. Well, really a Cartesian plane is that. It's just your x and y axis, right? So we don't need to talk about it maybe any more than that. Let's just actually go and use it. So here's example 1. You can read the blurb if you want, but here's example 1. Here is my Cartesian plane. Y-axis is the vertical, x-axis is the horizontal. Maybe we remember the x-axis. X is like a shorter letter, or it's smaller. So it would be the flat one, and y stands straight up. It's the tall one, so it goes up. Yeah, maybe you remember it that way. I have my x and y. Okay. All this is asking us to do is write the coordinates of points. So I've got a bunch of points on that Cartesian plane. Well, first thing to consider, a point always goes x, comma, y. Meaning, what value did I go along the x-axis? And then what value did I go along the y-axis, or up, down? Okay, it's you run before you jump is how they teach in 7th grade. So A. Well, A, along from the center, which is called the origin, A would be over 2. Okay, so I would have a point of positive 2, comma, and it goes up 1, 2, 3, 4. So A has an ordered pair or a coordinate pair of 2, comma, 4. X is 2, y is 4. Okay, B, starting at the origin, starting in the center, I go backwards 3 in terms of x, so backwards we say is negative. And then in terms of up, down, you actually don't go up or down, so your y value would be 0. Okay, so this is a pretty good review of stuff we already know. Okay, point C from the origin is 1, 2, 3, 4, 5, 6 over, 3 down. So positive 6, comma, negative 3. X is 6, y is negative 3. D is just beneath the origin. So in terms of x, I don't move left or right. I have an x coordinate of 0. And I go down 3. So my y would be negative 3. And lastly, it asks for the origin. Okay, well, the origin is 0, comma, 0. Okay, we call that the origin. All right. It says write the coordinates of the point in the second quadrant. Well, that means I better remember what the quadrants actually are. Okay, and the order of the quadrants, it's a little awkward. The first one, okay, quadrant 1, which we use Roman numerals, so the I, is the top right. And then what I'm going to do is I'm going to travel around in a circle. So I start from quadrant 1 and I travel around in a circle, labeling the other ones. It looks like a C. So 1, travel around to quadrant 2, down to quadrant 3, and quadrant 4 would be the bottom corner. Okay, so those are the quadrants. Those are important to know, and that's important to know just to be able to talk about points and really nothing other than that. What coordinates are in the second quadrant? Okay, well, quadrant 2 is over here. That would be E. Okay, and I'm not going to write, I'll just write E. I won't actually write the point anymore. Oh, never mind, we haven't done E. So that's negative 2, comma, 3. Okay, quadrant 3, okay, well, that's F, which is backwards 4, so negative 4, and then down 3, so negative 3. Okay. Complete the following table using positive or negative. So this is really interesting, and this comes up kind of later on, and in 20 you jump back to it. if I have a point in each of the quadrants, I actually know something about its signs. If I'm in quadrant 1, the only way you got to quadrant 1 was by going in the positive x direction and then up, which is the positive y direction. So it had to be a positive x value and a positive y value. If I'm in quadrant 2, the only way I get over to quadrant 2 is by going backwards, so a negative x, but then still up, so a positive y. So I'd have a negative x and a positive y. And I can know where a point is just based on the sign of its x and y values, because those are the only way I would get into that region. Okay, quadrant 3, you'd have negative x, negative y, because you go backwards and then down. Negative, negative. And the last quadrant, you're positive in the x again. You're going forwards, but then you're going down after. Okay, so just interesting to know. All right, and then there are points that wouldn't fit within this. Okay, not on a quadrant would be the ones that are on the x or y axis. And those are when one of my coordinates is 0. And we'll talk a lot about those. Those would be called x-intercepts and y-intercepts. Okay, so they don't always fall in a quadrant. Sometimes it falls in the middle. And this would be our x and y-intercepts. Okay, we're going to go down and we're going to look at linear relation. And we're going to graph it and compare it. And this is something you would have done a lot of at the grade 9 level, is talking about a linear relation and graphing a linear relation and all of that. And we're actually going to dive into this more in the next unit, but we just talk about it in general for this unit. So here is the relation. It says 3 toothpicks are used to form a triangle. Okay. A second triangle is formed by adding 2 more toothpicks. A third triangle is formed by adding another 2. And the pattern continues. So I've got kind of my first diagram, and then I've got another one, and then I've got another one. And then we could actually kind of foresee this going on and on and on and on. And it even says, draw the next 2 diagrams in the pattern. So I had 3 triangles. The next one, you would have 4 triangles. And then the next one, I'm kind of running out of space. I'll make it really small. I would have 5 triangles. Okay. So I actually did 5. And then it goes on and on and on and on. Okay. Well, we can talk about relations in a lot of ways. I can use diagrams to talk about the number of triangles to the number of toothpicks. I could use a table, which is what we're going to do next, to talk about the number of triangles to the number of toothpicks. I could use an equation, and I could even graph it. So what this unit is, it's all about the different ways that I can represent relations or connections between things. Okay, so I drew the next ones. Let's fill out the table of values. When you had 1 triangle, you had 3 toothpicks. The next one, I'd have 1, 2, 3, 4, 5. The next one, I count them up. 1, 2, 3, 4, 5, 6, 7, 7. And I can count. And so whenever I'm building a table of values, I can, draw a picture, extend the patterns. I can look for things like that. Next one has 9. The next one has 11. Okay. We're going to turn that into an equation in a little bit. But first, let's go next. It says represent the data of the table of values on the grid. Okay, perfect. So I've got a Cartesian plane, and I actually only have quadrant 1. Here's my y-axis, which we're calling P for toothpicks. My x-axis, we're actually calling T for triangles. And I don't have any of the negatives. I just have quadrant 1. That's really all we care about for this example. Okay, well, I'm going to label the number of toothpicks. I could have 1, 2, 3, 4, or 5, and then it's going to keep going and going and going. And then in terms of the toothpicks, that was number of triangles. Number of toothpicks, we're going to go up the side here. And I have to figure out an appropriate scale so that I could put 3 and 5 and 7 and 9 and 11. I have to figure out how I'm going to show those. Well, let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. So I could just go 1 to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it just fits. And that's one of the challenges in this unit, is finding a scale that fits all of your points, doesn't cut it too short, doesn't leave a whole bunch of space around. That's something we'll work on later. So that one works great. So then I could say, well, if these are my t values, that would be the x. And if these are my p values, that would be the y. And I can plot my points. 1, 3, 2, 5, 3, 7, 4, 9, and 5, 11. And I've got this great straight line. It says, why does it make sense to join, why does it make sense not to join the points in the straight line? And that has to do with the type of data. And it's something we're going to actually touch on at the end of this lesson. But the reason being is I can't put a point kind of in the middle here. I can't have 1.5 triangles. I can't have 2.5 triangles. I can't have, like, even closer, 3.1. I can't have 3.1 triangles. There are very specific values I'm allowed to have, and those are the only ones that I'm going to put on my graph. So I'm not going to connect the line. Okay, that's called discrete data. We'll talk about that more. What I can do is I can put an arrow on the end of the line saying, yeah, my graph stops here, but this relation would keep going. I could say 613, 715, on and on and on and on. So I could still have the arrow. Okay. Describe in words the relationship between the number of toothpicks and the number of triangles. Okay. Well, what I would say is every time you add a triangle, you add 2 more toothpicks. Okay, so I'm not going to write that down. Maybe we'll just talk about it. But if I go to my picture, okay, I have a triangle. And then if I add another one, really I just have to add the 2 on the end. And then if I want another triangle, I add the 2 on the end. Then if I add another triangle, I add the 2 on the end. So really all I'm doing is I start with this base triangle with 3 sticks. And then since I'm joining on a pre-existing end, I really just need 2 more. Okay, that's all I need. So yada, 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 I said it out loud. Write an equation. Okay, the number of toothpicks, which was P, equals, okay, well, what we said was I start with my base of 3 plus every time I add a triangle, I'm getting 2 more toothpicks, so 2 more T's. And what I'm actually going to do, I'm actually going to write that in the opposite order. I'm going to say it's the 2 toothpicks plus 3. So this was my original triangle. I had 3. That's always going to be there. And for every triangle I add, I actually am adding 2 more sticks. Okay, so there's my equation. And we work on finding those, and that's a skill from grade 9 and all of that. Okay, so I can graph this relation is represented by this graph, and it's also represented by this table of values. Okay, use the equation to determine the number of toothpicks if there are 27 triangles. Well, this is a grade 9 skill and an algebra skill, and it's really, really crucial. Okay, it says use the equation to determine the number of toothpicks. So that's saying P is my question mark if there are 27 triangles. So that would be T is equal to 27. And the great thing is I have this formula, this equation that deals with P's and T's. So I can say 27, plug that right into here, and then I'll be able to solve for P. P equals 2 times 27 plus 3. Or P equals, well, that would be 54 plus 3. P equals 57. There would be 57 toothpicks if you wanted to have 27 triangles. Next one says use the equation to determine the number of triangles. So that's saying T is your question mark if you have 83 toothpicks. So this one, if I look at my equation, I actually have P. I have P is equal to 83, and I'm looking for that piece kind of on the inside. Replace P with a number you know. And then this would be an algebraic problem where I have to work backwards and I have to solve, which I can totally do. Take away 3, take away 3. 80 is equal to 2t. Running out of space. divided by 2, divided by 2. 40 is equal to the amount of triangles. If you had 40 triangles, you would have 83 toothpicks. So once we have an equation, we can work with this relation. We can find values. We can do all sorts of stuff like that. That's fantastic. That's really good. Okay. Let's move on. Okay, we've got another example where it asks you to graph this one. And it's a little bit different. This one, if I have time, if this video is not too long, I will include it. If not, we're just going to skip right to the next one. So I guess you'll find out. Maybe the video goes in and does this, or maybe we're just going right on to the next one. Okay, I'm going to do class example 3. I'll try to do it fairly quickly, and I've already done a little bit in advance so that it doesn't take up much time. This relation, it says students in a physics classroom determine the resistance in an electrical circuit by measuring the voltage, which is V, or volts, when a current, which we're going to go I, and that represents amps, that's the unit, was passed through the circuit. So we're talking about volts and amps. And then it fills out the table of values for me. I've got my current, that's kind of like the X, the voltage, that's the Y, and I've already got my graph labeled here. I picked the scale, squeezed it in, just barely had enough room, so we'll go with that. We'll call it good. Where there's this apparent relation. Okay, well, represent the data from the values. So 0.5, comma 6. 0.5. I made every 4 ticks a value of 1, and then 4 more ticks I'm at 2, 4 more ticks, so halfway would be 2 ticks. And 6, I made every tick going up vertically 2. 2, 4, 6, 8 gets me to 10. 2, 4, 6, 8 gets me to 20. So I would be the middle, and I would be 2, 4, 6. There's my first point. Okay, and then this one's confusing. It goes from 0.5 to 1.5. Okay, well, 1.5 would be in the middle. 18, well, that'd be just below 20. And then it jumps all the way up to 3. Okay, well, there's my input of 3, output of 36. 3 and 36. It's a little tough looking at the small grid, but I think that's good. And then it goes to 3.5. So the spacing is a little awkward, but that's okay. 3.5, comma 42. And the last one, 4, comma 48. So my points aren't very spread out, but there you go. And this pattern would continue on and on. I just kind of stopped talking about values. Well, then it says, does it make sense to join the plots together? So I have to think, could I perhaps have values in the middle? Like, could I have a current of 1 amp? Yeah, I think so. It would probably be about here. Could I have a value of 2 amps? Yeah. 2.5. Yeah. Amps, I think, and I'm not a physics teacher, but amps are something that would just go up and down. It's a value I could record. It could have a whole bunch of decimals. It's what we call continuous data. And the same thing with volts. Volts are just a reading, right? They're just something that I could actually calculate. So what I would do is I would get out my ruler, or in this case, just a straight line, and I'm going to connect all of those points. Okay, and we do that with a straight line as best we can. So if you don't have a ruler at home, maybe you have your calculator cover, and you could use the side of the calculator cover. Works really, really well. So yes, and I'll just say it's continuous data, and we're going to go through that definition on the next page. Discrete versus continuous. Okay. Then there's something interesting. It says use the graph to determine the voltage for a current of 2.5 amps. Well, this is something called interpolation, and it's where I say if a point exists on a graph, I could find its x-coordinate or its y-coordinate. So if it gives me the amps, 2.5 amps, that's the I or that's the x-axis. And I'm going to find that 2.5 would be right here. So what you're saying is what point on my line has a value of 2.5 amps? And how I can do this, okay, how I could do this is I could say, go straight up from that point. Well, there's the point on the line. And then if I want to know what y value it is, I would go horizontally over to the y-axis, and there it is. Your y value, or in this case the V, the voltage, would equal 30 volts is my unit. Okay, so that's called interpolation. It's where I say, if I want to know this x value, I go straight up to find the point on the graph and straight over to the y-axis. And it actually works the other way. If you wanted to know when something had 40 volts, you'd go straight over to your graph, see when that happens, and then go straight down to find the value. Okay. Next thing, it says write an equation expressing V in terms of I. So this is saying V equals, well, this equation, and this is something we do in grade 9, is 12I. It has a slope of 12, and it has a y-intercept of 0, meaning I'm not adding or subtracting anything. Don't worry about those details. We'll spend more time on finding the equations. I'll just give it to you for this one. And then it says, use the equation to determine the voltage when the current is 6.2. Okay, well, so 6.2, that's the amps. That would be your I equals 6.2. And the voltage is my question mark. Okay, well, I just used the formula 12. Plugging in, I would put it in brackets. 12 times 6.2 equals 12 times 6.2, 74.4 volts. So I could use an equation. I also could have maybe gone to my graph and did a little interpolation. Okay. The resistance R ohms is calculated from the equation. We're going to skip that one. It's kind of a weird question. It's honestly more of a physics question than anything, so don't worry about it. And that is it for this one. So this is another example I could graph. This one happening to be continuous data versus discrete. And now we'll move on to the last page. And here we are on the last kind of question and last bit of information, discrete and continuous variables. So we looked at two examples above, or maybe we only just looked at the one. And there are two types of variables, and you actually know this from grade 9. It's just a little bit of review. One is called continuous, and one is called discrete. And this is the values that I'm dealing with can either be continuous or discrete. Well, what continuous means is I can have every single value for that thing. Okay? So if we were talking about the distance between two objects, it could really be anything, right? The distance could be a certain amount of kilometers or meters or centimeters or millimeters or even lower and lower and lower and lower, and I could be as specific as possible. Okay, that would be continuous. Or time, right? You go to milliseconds or nanoseconds or whatever, or you could talk about speed and velocity and all those things where every single value is possible. Whereas discrete variables, well, that's when there are only specific values that make sense. Okay, like the number of people in a classroom. There are only 30 people in a room. There can't be 30 and a half. There can't be 30.2. It's either 30 or 31, right? Or things like that, where it's very specific. There can only be a set, okay, type of thing. All right. So let's look at a couple examples and see if they're discrete or continuous. The time taken to complete a 100-meter sprint. Really, the key thing there is time. Time is continuous. I can have minutes, seconds, milliseconds, nanoseconds, on and on and on to be as precise as possible for how long it took them to finish that. Okay. The number of students who pass Math 10. That's discrete. Okay. Your grade is continuous. Your grade can be a number. The decimals could go really, really, really far. But you either passed or you didn't. So it's a certain amount passed, a certain amount didn't. That's it. Okay. I guess in this situation, everyone passes. So it's not too hard to figure out. Height of students. Okay. This one I could see people going back and forth on. The height would be continuous. We measure in feet and inches, or we measure in, meters and centimeters, but you could always go a little bit more accurate and a little bit more accurate. So you could be any height in the middle. Okay, you could be any height in the middle. Shoe size. Okay, this is the most confusing one or the most controversial one. Shoe size. Okay, I'm actually going to add an example and maybe we'll highlight the difference here. I'm going to say foot size. So to me, foot size is continuous. If I measure the size of your foot, it could really be anything, and we could be as accurate possible with measuring. But in terms of shoe size, you can only buy 9, 9.5, 10, 10.5, 11, 11.5, 12, or whatever, right? You can't buy, I can't go out and say, hey, I'd like a 10.75 shoe size, or I'd like a 12.3 shoe size. There are very specific ones that you can have. So shoe size would actually be discrete, but foot size would be continuous. So that's a kind of an interesting one. Okay, that is it. Okay, a couple of questions for you, or more than a couple. There's your homework, 1, 2, 4, and then 9 to 10. And yeah, that's a good start into relations and functions and gets us set up so that we can jump into some new material tomorrow. So as always, ask questions, set up one-on-one appointments, all of that. And that's a lesson for today. And that is it for today. That is our first lesson in the new unit relations and functions. Well, we're just kind of comparing, two variables and discussing relations in a general sense. So do the homework, ask lots of questions, submit it in the form, all of that. And that is it for today. Just to maybe a heads up, we are definitely going to need a graphing calculator for this unit. So that's the TI-84. Should have had this ready. Looks like this or very similar to it. There's TI-83, 84, 85. I'll put out a little video and some instructions in a bit explaining which one you need. But if you already have it, make sure you're getting that ready. And there's also a way to get one for free online. And I will send you those links down the road to make sure everybody has access to at least some version. Maybe it's a physical one, or maybe it's just the free online one. So that is it for today. Smash the like button, hit subscribe, all of that, and tune in again tomorrow for another video.